Hi and a very good day everyone. My name is Shahmi and my group 11 will be presenting our ARAM group project. So as an overview of this presentation, we will include the introduction, our data analysis using Weibull, our initial and final RBD comparison, and also our conclusion and recommendations.
For the background of the project, we, as a team of engineers, are required to conduct a case study on natural gas processing plant reliability block diagram model. The RBD consists of blocks and sub-diagrams which represent the equipment and subsystem for the natural gas processing model. This project has three objectives. Firstly, to evaluate the overall availability of natural gas processing plant for 5 years based on given dataset. Secondly, to identify critical equipment which affects the plant overall availability. And lastly, to propose and justify adjustment to the plant system to achieve 99% of plant overall availability. This case study was conducted using Weibull and Blockstream software. The given live data were loaded into Weibull to find the best fit distribution for each equipment data and their respective parameters. The obtained parameters were then loaded into Blockstream blocks for each equipment to analyze the plant overall availability. Then, adjustments were made to the block diagram to achieve 99% of plant overall availability.
My name is Fatiha from Group 11. The project initially was provided with total data size of 90 equipment of separator, slug catcher, turbine, and etc. Then the raw data looks like this. There is total time of failure and the mean time to repair. To understand this raw data, simply imagine that this figure right over here represents time taken for separator to fail. These dots respectively represent the fail, and assume that we have a scheduled inspection where we inspect equipment at a regular manner. From inspection, we identified that the equipment have failed, and when it did, we record it in TTF. And the mean time to repair represents the time taken to repair the equipment when it fails. We already have our raw data just now, so we input the data into live data file in available right over here. Now we would like to identify which distribution, either log normal or Weibull distribution, suits the data that we have collected best, because these two distributions were the main interest in this semester. So click on the distribution wizard. Then the prompt dialog will show this. Select the distribution of interest and click analyze. It will show the ranking of the best fit for our data. For this case of our separator, Weibull is the best fit of our data, hence we choose implement. After we choose implement, the simulator will report our distribution parameters. In this case of our Weibull distribution, we got the parameter of beta is equal to 1.22 and eta is equal to 2484.21 days. The beta we got over here is right between 1 to 2, which indicates separator's early way out, and our eta is actually to approximate to our MTBF, mean time before failure. For the rest of our equipment, we need to load all the TTF and MTTF data into our live data file in Weibull++ and identify which is the best fit distribution, and record the parameters to be used for our Blossom simulation for the rest part of this project.
By inputting the best fit Weibull or the log normal for every TTF and also the MTTR, this is our RBD and this is our initial availability, which is 92.71%. To increase the availability to 99%, we did adjustments which only include adding standby units. So here we have 7 subsystems that have the new standby units.
After the adjustment done by adding standby equipments for the critical equipment based on the RSFCI, which stands for the Reliance of Failure Critical Index, the availability increases from 92.71% to 99.19%, which shows that any failure will not hugely affect the production performance. The increment of 7% is huge because the data involved in producing this number requires a lot of effort both in analysis and execution in real life production process. These slides prove that the addition of standby equipment really contributes to the plant operation, because as you can see initially, even if the availability is high for the driver turbine, the criticality of the failure is still high with an 89% value, and then it will produce a low overall availability for the plant. And by adding standby equipment, Any failure will not bring huge risk to the plant, which will result in higher production performance. And the value that we get after the adjustments is 26% for the discharge drum.
Assalamualaikum. My name is Muhammad Shafiq from Group 11. After the adjustment, there are a total of 14 standby units added to the RBD. In the main system, there are 2 standby compressor and 1 standby motor added. In the MP separation and compression, there are 1 standby drum and 1 standby motor added. For feed gas compression, there are 1 standby drum, 1 standby compressor and 1 standby motor added. For the acid gas removal, there is 1 standby separator added. In the amine regeneration and sulfur recovery, there are 1 standby separator and 1 standby pump added. In the dehydration, there is 1 standby separator added. For the natural gas liquids recovery, there are 2 standby separators added.
To conclude, the plant are able to achieve 99% overall availability with the implementation of proposed adjustment in the RBD model. The introduction of standby units prevent disruption to the plant operation in case of equipment breakdown. We are also able to reduce the failure criticality index for each individual equipment, which lowers the system downing failure triggered in the system. As recommendation for future improvement, firstly, we can implement load sharing in the system design to reduce the stress applied to the equipment. This will improve their expected lifespan, which also reduce the frequency of failure. Secondly, we can increase the M out of N parallel redundancy arrangement used in the system. This will reduce the individual equipment failure criticality index as long as the minimum number of equipment running is satisfied. This will prevent system downing failure from happening and allow concurrent repair work to be done on failed equipment. That is all from us. Thank you.